Welcome, data structures fans. Today I'm going to make a short video about hash tables. Hash tables are really cool. We're going to use them to sort some names and do some other stuff, but first we have to figure out what they are and how to use them. You'll see that we're going to use some of our old tricks to sort our names out, as in switching a name into a number, but we'll get to that in a little bit. Let me move my cell phone. Sorry about that. Oh, crap! Oops! Dang it! Spluttered a bug. You know, you guys, I'm sorry about this. Bugs are part of computer science, and, it just is. Hey, let me get a clean page. No! Another one. Holy crap, I got him. Oh, I got him. Ooh! Yuck. Oh no. Another bug. Sorry about that. Oh boy. That bug seems to be filled with some gelatinous white juicy stuff, somewhat like mayonnaise. Okay, hash tables, or in our case today, smash tables, because we had to smash a lot of bugs. So a hash table is going to be set up like an array. Let me get a little bit of a writing down here. Hash table. So really, a hash table is a big array like this. And what we do, so this is 0, 1, 2, yada, 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 yada. This stupid guy right here is in the way. It's probably going to mess up everything. What we do is we use a characteristic of the data to directly compute where we're going to store the data. For instance, suppose I have some part numbers. How about these part numbers? Or some parts. Nut, bolt, screw. How about, I'm running out of ideas here. So suppose this is 4403. This is 4407. This one's 4802. So suppose, well, we need one more, 5619. So suppose we wanted to put the information about each one of these directly into our table. We could come up with some sort of a hokey, and in this case it's going to be hokey, function to calculate the index. How about this one? So let's do this. Nut equals 4403. So what I'm going to do is, for my first hash function for this, I'm going to take the last two digits and subtract it from the first two digits. So my hash index will equal 44 minus 03, which is equal to 41. And then I'll take all my information about the nut, and I'll put it in array spot 41. And then so bolt would be 44 minus 07, which is, yowie, what is that? It's a good question. 37. Screw that equals 48 minus 02, which equals 46. And I'm running out of space. Sorry, let me do this. The hammer. That would be 56 minus 19, which is 37, which therein lies a small problem. Notice we have two 37s. I didn't actually do that on purpose, but when we try to put information in two in the same place, we have what's called a collision. So a collision is caused when two unique pieces of data generate the same hash index. Two unique pieces of data generate the same hash index. So in this case, we got to figure out what to do. Let me switch pages real quick. I don't know if you can see that. I barely can. Let's see if we can sketch this out. We have here, that's right here, 35, 36. Jeez whiz. How do you get a 67 from a 36? 36, 37, 41, 42, 43, 44, 45, 46. Oops. 47. Okay, so we have nut at 41. So nut is here. We have bolt here. We have screw at 46. And we have, hammer wants to go here, like this. But we can't put it there because bolt is there, so we have to come up with a way to handle the collision. Sometimes a collision is called a hash clash. In here we're just going to call it a collision. I think that hash clash thing came from like the 80s or something, when you had these British bands like the Clash, you know. Yeah, baby. So we're going to call it a collision because we're like modern people and whatnot. So when we go here, an easy way to handle a collision, and that's the way we're going to do it, is just to bop on to the next available spot. We don't have anything in 38, so we're going to put hammer there. Now, how is this good? Well, for one thing, when we put stuff out there, we're not doing any kind of a sequential search or anything like that. That we're just calculating where it's going to go directly from some data characteristic. So putting stuff into the table is order of 1. Removing stuff from the table is order of 1. Now this thing that I did here is not real good, mostly because it gives us no real order. Let's try to do something a little bit better that'll give us some order. Here I'm going to write down some names. No, I'm not. Yeah, I am. Annie, and some heights. Name. Like this. Height. Okay, so Annie is 5'4". Tim, he's, what's the average height of a dude? 5'9" maybe? I don't know. Bob, 5'7". Doug. Oh, Doug's not 5 anything. He's tall. He's 7 foot. No, he's not. Yeah, I guess he is now. 7'3". Bill, 6'2", and John. Let me wiggle the mouse here. John is 4'8". Now this is just real quick. Okay, so I need to come up with a hash function for this. This time I want to use my hash function to impose some kind of an organization on my data, and that's not going to be too tough. I'm going to come up with a real simple thing, and so what it's going to be is like this. Oh, let me do it down here. Hash index equals feet times 100 plus inches. So, and let's just call this, well, we'll just do this, hash index, like that. So this one's going to be 504, this one's going to be 509, 507, 703, 602, and 408. That's what we're going to get for our indices. Now, if we put them in an array with those things, as you can see right now, we don't have anybody shorter than 5'4". So this first giant 500 and something things is going to be empty, or the first 503 things is going to be empty. So if this is, let's go, here is 500, here's 600, here's 700. So then, obviously Amy and most of them are going to be right up here. So all of these guys are going to concentrate their data between the first 12 spots, right? From 0 to 11, which is going to lead to a whole bunch of collisions. So we need to fix that too. The first thing we need to fix is this giant gap. Generally, let's say we're just doing this for people at the university. Generally, we would not have people at the university shorter than 4 feet. So what we can do is just fix this like this, just like that. Subtract 400 from it, and we will clean up this whole giant gap. Now that still doesn't save us here. So we can rewrite this like this. Hash index equals, let's go, feet times 100 minus 400. That's our first fix. And then we're going to put our second fix in here, plus inches times, let's go 8. Let's see, if we go 9, that's a little too much. Let's go 8. Why did I pick 8? Because 8 times 11 is 88. And I'm not going to have, if I go 9 times 11, that's 99. And that will only give myself one spot for somebody who's, say, 5'11 or 4'11. So if I go 8, I'll have several spots for that person. So each height will have 8 spots before they ruin our order. So if I'm to go ahead and put all of these people in here and then just print the table, all the occupied places in the table out, I will print them out by shortest to tallest person. Now, I can put them in there by name and come up with a hash function for that, and that would be pretty easy, and I would end up sorting them. How would I do that? I would do our same equation like we did here. It would be, I'm just going to do it for 2 letters. First letter times 26 to the first plus second letter times 26 to the 0 power. So the first 2 letters would be used to sort this out or to calculate this. Now this is going to be kind of bad because we'll end up with this giant gap. So we'll have to end up dividing this by something. The way you figure out what to divide it by is, well, you got to figure out what the maximum is. So let me go over that real quickly. So if the first 2 letters of the name, let's try this, Aaron, or as Key and Peele would say, Aaron, that would be A times 26 to the first plus A times 26 to the 0. A is equal to 0, so that's 0 there, plus 0 times 1. So this is equal to 0. Now, how about this? So this is going to be Z times 26 to the first plus Z times 26 to the 0. So this is 25 times 26 plus 25 times 1. Let's see, we got to do this math-wise. So 25 squared is 625. We need one more 25, gives us plus 25 there. And then we have one more 25 over here. So this is equal to 675. So our last index that we can calculate is 625. Our first index that we can calculate is 0. If we want to fit this thing into, say we want to fit it into an array that goes 0 to 100, what are we going to do? We got to divide this thing by something to get this a little bit smaller than 100. So we write an equation, 675 over x equals, let's see, how about 95? Because we might have ZZ top, we might have ZZ bottom, we might have ZZ middle. So we got to handle our collisions. So we'll allow a little bit of space there. So how do you do this? Math it out. How about like that? Equals 1 over 95. Yuck. X equals 675 divided by 95, which equals some fun number right around 7. And here we go. 675 divided by 95 equals 7.1. So that's our divisor. So now our equation, if we want to fit all of our names into 100 spots, is, I'll write it out right here, hash equals first letter times 26 to the first plus second letter times 26 to the 0, and we divide it by 7.1. Please look at your notes and read them. We have some criteria for a hash function. It goes over that. We kind of actually covered it, but I didn't say it explicitly. Sometimes we want an order, sometimes we don't. We definitely want to be able to have room so that we don't have lots of clashes, and we definitely don't want these giant empty spaces in the front. So look at your notes, and I'm assigning a program on this. It's pretty easy to write, and there's bunches of clues in your notes on the program. Thank you.